Alright, so here we're going to take a look more definitely about substitution, a way to solve a system of equations, as well as elimination. And when we talked in class about the dogs and cats and looked at different ways, we kind of used these ideas, okay? But first of all, substitution, okay? Here's the steps. So, we're given a system of equations. What we're going to do is we're going to take one of these equations, okay, and we're going to solve it for y. So, y minus 3x equals negative 3. So I'd add 3x to both sides, giving us y equals 3x minus 3. Okay, that's where that came from. Then, because that is equal, just like in cats and dogs, we got one of the either bags of cats or bags of dogs to equal the rest. We take that and we take the y value and we swap them. Because this is saying y is equal to 3x minus 3, so why not replace the 3x minus 3, or replace the y with 3x minus 3, okay? Then we distribute that 4, that's how we get negative 12x. Negative times a negative is positive 12. Then we simplify, we would subtract the 12 from both sides, right? So they took this y and replaced the 3x because they're equal. Okay, 26 minus 12, that gave us 14. Negative 2x minus 12x gave us negative 14. Divide by negative 14, and we get one of our variables. We get negative 1 for x. Okay, then you take that x and plug it back in here, right, as we can see right here. And then 3 times negative 1 is negative 3, minus 3 gives us negative 6. So an x value, a y value, that's our solution. Okay, and remember, when we're dealing with systems of equations, the whole idea is finding where they intersect. Okay, that's where the solution is. That's what we were looking here. Okay, and that's how we do it. So let's see a few examples. Okay, now notice these two are already solved for y. So I take this one and plug it in for that y. So instead of y, I get x plus 9. And then it's going to be equal to negative 8x minus 9. The beauty here is now I just have x's, just like with the cat and dog food. Now I just have one of the types. Okay, so we combine. I could add 8x to both sides, giving me 9x. Subtract 9 from the other sides, giving us negative 18. Divide by 9, and x equals negative 2. Okay, and that's half of our problem. So then, to figure out y, we plug in what we found for x. Negative 2 plus 9 gives us positive 7, y of 7, so our intersection point is negative 2, 7. Okay, so if we were to graph both of these, okay, we'd have at negative 2, positive 7, be right here. So I have one graph going this way roughly. The other one would be going like this. And so that's where they'd intersect. So this is just another way to take a look at that, okay? So let's see another example. Number 2, I've got y is just equal to that whole side. So this whole side is going to replace that y. So I get 5x plus 4. Instead of times y, it's now times negative 4x plus 10, because up here, y and that were the same thing. Okay, and that equals 19. So then we simplify distribution. Negative 16x plus 40 equals 19. Negative 5x, negative 16x gives us negative 21x. Subtract 40 from both sides, and we get negative 21x is equal to negative 21. Divide by negative 21, and we get x is equal to 1. Then I take that x and plug it back up here. Replace the x. That'll tell us what the y value is going to be. So we get y equals 6. So my point, 1, 6. That's the answer, the solution where they intersect. Okay? Alright, let's take a look at this last one. Okay, now nothing's solved for y. So I need to pick one of my equations. I see this single y right there. So I'm going to solve that one. So I get y is equal to negative 11 minus 2x. Then I take that y, and because negative 11 minus 2x is equal to it, I replace that y with it. So we get 4x plus negative 44 minus 8x equals negative 24. Add 44 to both sides. We get 4x minus 8x, which becomes negative 4x. Negative 24 plus 44 becomes positive 20. Divide by negative 4, and x equals negative 5. Then I can just replace that x with negative 5. So we get negative 11 plus 10, because negative 2 times negative 5 is positive 10. And so y equals negative 1. So the point negative 5, negative 1 is where those are going to intersect. Okay, and so that's kind of how we use substitution. And again, it's just one way of solving a system. So we've already dealt with graphing. We can easily use graphing to help. Now we have substitution, way to do it if you're not graphing. And then we're also going to take a look at the third one called elimination, which is typically the one we like more. Okay, so with elimination, again, it's dealing with like we did in cats and dogs. This is a one where with elimination, where we did the cats and dogs and we tried to find the difference in the cost and used that idea. So given two equations, first we make sure the x's, the y's, numbers, equal signs are all lined up. Then what we're going to do is we're either going to add or subtract the whole thing, just like we would used to go 10 plus 20 to get 30. Okay, that vertical addition, doing the same thing. So I'm going x plus x, which gave me 2x, 1y plus negative y, which gives me 0y, which I know is 0, so we just eliminated it. Okay, and then 2 plus 14, which gave us 16. So the trick here is that we eliminate one of the variables, just like we eliminated one of the dogs or cats. We're able then to solve using the other one. Okay, and sometimes you need to manipulate an equation to make it work. Then once we find out what x is, we go back to one of these equations. Looks like they used the top one. And instead of x, we put 8 in because we know that's what it's equal to. So then I solve for y, and I get y equals negative 6, and I find that intersection point. Okay, so for elimination, first we make sure they're lined up. Okay, as we can see, they're lined up here. Then I decide, do I add or subtract? Well, I've got 5y and 5y, negative 5y and positive 5y. If I add those, that would give me 0y. So I add everything else. Negative 6 plus 4 is negative 2x plus 0y. Negative 12 plus negative 2 is negative 14. We eliminate that. Negative 2x equals negative 14. Divide by negative 2, x equals positive 7. Then I grab one of these equations, and instead of x, I put in our new value of x. Then we solve for y, and we get our y value of negative 6. So my point, 7, negative 6, that's where these guys would intersect. Okay, that's what our answer is. All right, now looking at number 2. Okay. Again, same idea. They're all lined up already, right? X's, Y's. Now, if I add a negative 8 and a negative 8, it's not going to get rid of it, nor is it going to get rid of the Y's. So in this case, I subtract. Because a negative 8 minus a negative 8, that's like positive, would give me 0x. Negative 3 minus negative 4, it's like plus. So plus 1y equals 3 minus 12, which would be negative 9. So I get 1y equals negative 9, basically y equals negative 9. Pick one of these, doesn't matter which one. Let's go with the top one. Get negative 8x minus 3 times negative 9 equals 3. Negative 8x equals positive 27, plus positive 27 equals 3. Subtract 27. And 3 minus 27 is negative 24, so negative 8x equals negative 24. Divide by negative 8, and we get x equals positive 3. Okay, we pick one of these equations. Or, no, we already had the y, didn't we? So, my point is 3, negative 9. That's where they intersect. Okay, and finally, if we look at this last one, okay, number 3, they're not the same, are they? But could we make one the same? Well, a negative 5 can become a negative 10 if we double it, or a negative 5 can become a negative 15 if we triple it. So we'll just double, because smaller number. So I've got negative 10x minus 15y equals 20. Double it to be negative 10x minus 10y equals 40. So negative and a negative, so I'm going to subtract again. So that's 0x. Negative 15 minus a negative 10 becomes a negative 5y. 20 minus 40, negative 20. So negative 5y equals negative 20, divided by negative 5, and we get y equals a positive 4. Then pick one of our original equations, plug in the 4 for y, and we solve, and we see what we get. Add 20, get negative 5x equals 40, divide by negative 5, x equals negative 8. So again, this is where they intersect. That point is where they intersect. Now, in case you were wondering, doesn't matter which equation I use. Even if I used this different equation to solve, once I got the y to solve for the x, we'd still end up getting the same answer. As you can see, as I solve it. Okay, so there we go. That's how we use elimination, substitution, and we know how to graph, especially using our graphing calculators. And we can use any one of those ways to help us solve an equation. Well, a system of equations, I should say.